So all I'm going to be showing you in this video, really quickly and simply, is how to calculate the average atomic mass of different elements based on the values you're given. So in any of these problems, you're going to be presented with in the first few examples, just a set of two different isotope masses. So you're going to be given a mass number for an isotope and the percent abundance. All right, that is, again, that's how much of the average out of all so like in this first example, out of all the boron that exists, 19.78% of it is boron 10, having a mass number of 10. 80.22% of it has a mass number of 11. And you're just going to calculate the weighted average of those two to see, like, okay, how do I do this? And then what is the average atomic mass of boron that you would see on the periodic table? So I'm going to be showing you how to do that. This will only take a second, and then I'll do a harder example also. So if you look at this, you've got your boron here. Now you've got the mass number of 10. That's what you care about. So you know you have a mass number of 10. So you're just going to simply write out 10. Now the big thing that you have to remember, you have to convert this percentage to decimal form. Remember, any percentage can be converted to decimal form, and that's what we're going to do. So I'll write it big up here so you can see. So we've got 19.78%. Now, how do you convert that to decimal form? Well, you're basically going to divide by 100. Simpler version, though, is just move the decimal point over 2 spots. So that will become 0.1978. All right. So you'll put in 0.1978. All right, that's how you're going to do this. Then you have another isotope with another percentage. You're going to do the same thing again, except now it'll be 11, and then you'll have 80.22. You're going to move the decimal point over 2 spots again, which is the equivalent of dividing by 100, and that'll be 0.8022. Now, the next step, I mean, that's it. That's the problem. Now you just got to get the answer. The next step is basically just go and figure it out. So this is why you have a calculator. They're useful for these things. I strongly encourage the use of them for this type of stuff. So you're just going to do 10 times 0.1978 plus 11 times 0.8022, and you get, we'll just say 10.8. All right. Make sure when you do this that you're following order of operations. Make sure that you are multiplying this together. When I typed it into this calculator, it worked because it did multiplication and multiplication, then it added the two numbers together. Make sure when you're doing this otherwise that you're going to multiply these first, then add them together. All right. Now let's see, did I get this right? So this is boron. This is the chemical symbol boron. So how do we check? We look and we say, okay, so the average atomic mass of boron on this table is 10.81. So we've got 10.8. Yeah, that's right. It's not exact because this is a little bit of a simplified example here. In reality, there's more isotopes, there's more stuff that goes along with this. But for simplified purposes, there you go. You did it right. Now again, on the test or quiz or whatever it is, however you're going to be assessed on this, do understand though that you're not going to get a problem like this and it's going to say like, okay, figure out the average atomic mass of boron, and then you can just, if you're smart, you can just be like, well, I know what it is. It's right here. It's 10.81. Like, no, it'll be a made-up element where you're just going through and you're doing the calculations for an element that you aren't familiar with, that you can't just look up. Now, I'm also going to do number 8 here, just something a little bit more complicated, where you have 3 of them, because it's the exact same process, but it can't hurt to do another example. So, next example here, we've got silicon, so we've got Si. So we're going to do 28 because we have a mass number of 28 first, and then we're going to move the decimal over 2 spots. So we're going to multiply that by 0.922. You're going to add it to the next one. So we got silicon 29. Now, if there's only one thing kids get wrong in this, and it's what I'm about to show you. This is the only thing people ever do wrong, you know, if they're paying attention. So you have 4.7%. Now remember, when we move the decimal over 2 spots, we're basically just dividing by 100. So you need to remember that, like, you are going to have to move the decimal over 2 spots here. So there's only 1 spot really to move it. So you're going to have to do it again. Now, what do? You write a 0 before it. So this isn't 0.47. This is actually 0.047. Okay? That is the only thing people goof up. You need to move the decimal over 2 spots, not 1. Even if there's only one digit, if it's a single digit percentage, you still have to move it over twice. So then you'll do the same thing for this last one. You'll do 30. Same deal, you got to move it over 2 spots. So you'll do 30 times 0.031. And it's just a matter of doing all this. So 28.0 times 0.922 plus 29 times 0.30 times 0. So there's the calculation typed in. You hit enter. You get 28.109. So 28 point, we can say just 28.1. Keep it simple. So again, you look and you're like, silicon's 28.09, 20.1, we're good. You know, it's, again, these are simplified examples. But you check, and that's, now if you got like 50, you did something wrong. If you got 27, you did something wrong realistically. I mean, it should be very, 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 very close. So like for this last one, number 10 here, I just wanted to, you know, I'm not going to do it, but I just wanted to show you, like, you know, just make sure that you're converting this properly. It doesn't matter how many you have. You just do the same thing where you add it all up. All right? It's no different than calculating your grade like we talked about. And do remember, like, so even if something like this, so like let's say you have 0.65%. So let's say you have 0.65%. You still got to move the decimal over 2 spots. So 1, 2. So your final thing for this, it'll be 0.0065. That's the only thing people can get wrong. So as long as you remember to make those conversions properly, you should be fine.